Aging is no longer viewed as a fixed destiny determined solely by the number of candles on your birthday cake. Today, science is uncovering ways to measure not just how long we've lived, but how well our bodies are holding up to the passage of time. This is the distinction between chronological age and biological age, a concept that has transformed our understanding of what it truly means to grow older. While chronological age is simply the number of years since birth, biological age attempts to capture the actual state of the body's internal systems: how effectively your heart pumps blood, how well your cells repair damage, how inflamed your tissues are, how youthful your immune system remains. And in many people, those two numbers, chronological and biological, can differ by years, even decades. Being biologically younger than your calendar age can be an enormous advantage. It means your body is functioning at a higher level than what would typically be expected for someone your age. Your risk of chronic disease is lower, your recovery from illness is faster, and your resilience against environmental stress is stronger. Scientists now use a variety of tools to estimate biological age, and one of the most accessible comes from analyzing patterns in routine blood biomarkers. Factors like fasting glucose, triglycerides, white blood cell counts, liver enzymes, creatinine, albumin, and markers of inflammation such as CRP provide a detailed snapshot of how your organs and systems are functioning at a given point in time. These markers can be fed into sophisticated algorithms that output an estimated biological age, offering a far more individualized and precise picture of health than simply looking at someone's date of birth. The science doesn't stop at blood. One of the most cutting-edge approaches comes from epigenetics, the study of how lifestyle and environment influence gene activity. Researchers have developed what are called epigenetic clocks, which track changes in DNA methylation, a process that naturally occurs as we age and influences which genes are turned on or off. These methylation patterns are surprisingly accurate predictors of biological age and even of disease risk and mortality. In fact, epigenetic age is proving to be one of the most powerful tools available to predict future health outcomes. What makes it particularly exciting is that these patterns aren't set in stone. They can change in response to how we live. Lifestyle, in many cases, trumps genetics. While our genes may set the initial conditions, how we eat, move, sleep, and manage stress can either accelerate or slow down the biological clock. Studies have shown that people who follow Mediterranean-style diets, rich in plants, olive oil, fish, and nuts, often appear biologically younger than peers on standard Western diets. Regular exercise, especially when it includes both aerobic and resistance training, supports mitochondrial health and slows cellular aging. Even sleep quality and emotional well-being influence inflammation and gene expression, shaping biological age in subtle but significant ways. In some studies, individuals who adopted targeted interventions, such as stress reduction techniques, optimized nutrition, and daily movement, reduce their biological age by as much as 3 years in just a few months. This shift from focusing on disease treatment to health optimization is already changing the way longevity is approached. Rather than waiting for problems to appear, scientists and clinicians are moving toward a proactive model. Track your biological age and adjust your lifestyle to keep it younger than your actual age. The implications are profound. It means aging can become a more flexible process, one that reflects not just the passage of time, but the accumulation or reduction of biological damage based on how you live. In communities known for exceptional longevity, such as the centenarians of Salento in southern Italy, this idea becomes real. These individuals often show biological markers of youth even in their 90s and 100s. Their inflammation markers remain low, their immune systems are resilient, and their metabolic health is surprisingly robust. Their biological age seems to lag behind their chronological age, allowing them to remain active, cognitively sharp, and socially engaged for far longer than average. These observations support the idea that aging is not purely mechanical or genetic. It's an adaptive process that can be slowed, or in some cases, partially reversed. The real promise of biological age is not in giving us a new number to obsess over, but in offering feedback, a way to understand how our bodies are responding to the choices we make. Unlike chronological age, which only moves forward, biological age can fluctuate. It offers a path toward empowerment, giving individuals the data they need to make meaningful changes and measure their impact. In the years ahead, biological age may become the standard metric for preventive medicine and longevity planning, helping to usher in an era where the goal is not just to live longer, but to live better and younger for as long as possible.